substitution, and where you could factor and cancel. So today, we're going to look at a few different things that you can do to solve these types of problems. So the next one that we have that we're going to look at, I think, yeah, we did all those. So the next one we have we're going to look at is going to have a square root in it. So we always should try direct substitution for these problems. So if we look at number 8 here, we would have the square root of 1 minus 1 over 1 minus 1, which would give us 0 over 0. So 0 over 0 does not tell us an answer. It just tells us we need to keep going. So the trick that we are going to use whenever we have something like square root of x minus 1 over x minus 1 is we are going to rationalize whichever side has a square root. Typically, we have been, we rationalized the denominator is what we did whenever we were doing radical sort of stuff, right? We didn't want that square root in the denominator. When it comes to limits, if we can get rid of the square root on whichever side it's on, we can probably cancel something out eventually and solve the problem. So, to rationalize when I have square root of x minus 1 is going to be a little different than if I just had square root of x, right? Because if I've got 1 over square root of 3, you guys are pretty good at doing square root of 3, square root of 3, and getting square root of 3 over 3, right? What do I do if I have a plus or minus? What if I had like square root of 2 plus 1? Okay, we will multiply. It's called the conjugate is what it's called. So 2 minus x, or minus 1, I mean, on top and bottom, is what you would do here. So we're going to do that same thing here, but we're actually doing it to the numerator for this one. So I have square root of x plus 1, and we'll multiply by that in the numerator and the denominator. And here is why that is helpful. If I multiply square root of x times square root of x, I'll just get x. And then if I do square root of x plus 1, I'll get plus the square root of x. Negative 1 times the square root of x will give me minus the square root of x. And then negative 1 times 1 gives me negative 1. I will tell you it is usually not helpful to multiply the denominator together, so leave it like it is. Yes? Yes. So the middle terms cancel here, and actually if I was doing this, I'd do that part in my head and I wouldn't even write this step right here down. I would go straight to this. Like this, and because we've got multiplication here between my x minus 1 and the rest of the stuff over here, I can just cancel my x minus 1s. And so now I have the limit as x approaches 1 of 1 over the square root of x plus 1. And if we plug in 1 at this point, we will get 1 over 2, so 1/2 would be my answer. Okay. Questions? All right, 9 is a little bit more complicated, but it's still the same idea. We've got the limit as x approaches 5 of the square root of x minus 1 minus 2 over x minus 5. So, again, it's this numerator we actually have to rationalize. You are only changing this sign right here. The stuff under the square root, you do not change its sign. So we'll do square root of x minus 1 plus 2 on top and bottom. And so when I distribute here, square root of x minus 1 times square root of x minus 1 is just x minus 1. Here I will get plus 2 square root of x minus 1, but here I will get minus 2 square root of x minus 1, which is why we picked this. We want those middle terms to cancel out, right? So that should be happening every time. So I'm not even going to write them down this time. And then I've got to multiply the last terms together. Negative 2 times positive 2 gives me a negative 4. Okay, so up here, x minus 1 minus 4, what is that? X minus 5. And I can cancel my x minus 5s. So I have the limit as x approaches 5 of 1 over the square root of x minus 1 plus 2. Now I want to try to plug in my 5. Square root of 5 minus 1 plus 2 is going to be 1 over square root of 4 plus 2, which is 1 over 2 plus 2. Which gives me 1/4. Okay, questions?
So for all of these, is it just, we're trying to find which one of these will work to solve it and plug in that as it approaches? Like you're trying
Yeah.
to step 1, 2, 3, and 4, like one might work while another doesn't work.
Correct. So, like when you see a square root, first of all, always check direct substitution. I didn't do that here. But if I had I would have gotten 0 over 0. So you always want to check direct substitution. And then there will be certain things about problems that might cue you to that this is what you need to use. So when you see that square root, you probably need to rationalize most of the time anyway. Okay, questions? Okay, here's another one. This one's even a little bit more complicated because it has an x squared. If we plug in negative 2, we will get, I should do this every time, I usually forget, negative 2 squared plus 5 minus 3 over negative 2 plus 2. You're going to get 4 plus 5 is 9, square root of 9 minus 3 over 0. That ends up being 0 over 0. So you're going to have to try something else. So here, we want to multiply by the square root of x squared plus 5 plus 3. And so when we multiply here, we will get x squared plus 5. The outside terms and the inside terms are going to cancel. So since they cancel, we're not going to write them down. And then we got to multiply negative 3 plus 3, which will give me a negative 9. And in the bottom, don't multiply those together because it will just make your life more difficult to keep them factored apart. It'll make things cancel more easily. Except for, this one's harder than the last one, because I've got x squared minus 4 over x plus 2 times the square root of x squared plus 5 plus 3. Does anything cancel? Not like it is right now. But, Paul, what could we do? So, as it is right now, I cannot cancel any of these x's or 4's with anything down here because they don't match exactly. But, x squared minus 4, it factors into x plus 2x minus 2. And if I factor it into x plus 2x minus 2, now something will cancel. This x plus 2's can cancel for me. So, at this point, we're going to plug in negative 2. That's going to be a square root of 9 plus 3. So we get negative 4 over 6, which will be negative 2/3. Okay, questions? Okay, so that's sort of the most complicated version of a rationalization you'll see because you got even that factoring thrown in there. All right, so next thing I'm going to look at is piecewise functions. Okay, so let's remind ourselves real quickly. I'm just going to graph it on Desmos because it graphs so beautifully there. So if we just remind ourselves of what this graph right here would look like. I'm typing in separate equations just because it's a little easier to do. All right, so I'll zoom out a little bit. This is the graph of what we're looking at here. So we've got a horizontal line here. We got this slanted line here. And then we got, this is a piece of a quadratic right here. But you're really only seeing just one little leg of the quadratic there. So this is what our graph looks like. So if we are asked to find the limit as x approaches negative 2 from the right, negative 2 is this purple line right here. So from the right, I am using this blue equation right here. It's my middle equation, right? So from the right, if I want to find what x approaches, I would use this middle equation because here at -2, this part right here would be on the left, this part right here would be on the right. This is a really simple equation, so we can just do direct substitution. -3 times -2 minus 1, we'll get positive 6 minus 1, so we will get 5. Okay. For 12, it asks us to find the limit as x approaches 5 from the right. So from the right, at 5, we're looking at these two equations right here. Both of them happen at 5. When you're talking about limits, it does not matter which one has the or equal to with it. Okay? Because when we talk about limits, we don't really care if it's an open circle or a closed circle. We're talking about what it approaches. So we would choose this bottom one because that's coming from the right side. Like if we think about graphing this, the right side, let me put in x equals 5 there. So x equals 5 is this place where these two functions come together, and this green graph, which is that quadratic, is on the right. So we would just plug in 5 to the bottom function. So we'd have -5 squared plus 4, which would give us -25 plus 4, so we'd get -21. If we are supposed to find the limit as x approaches 4 for f of x, 4 is not one of these places where our function splits, right? It's here between -2 and 5. So we're just going to plug into this equation right here. We don't have to choose between them. So we would have -3 times 4 minus 1. So it'd be -12 minus 1. So we get -13. Okay, 14 gets one that's a little bit more complicated to think about because it asks me the limit as x approaches 5 of f of x from both sides, right? So from the right, we found that we had -21 when we chose from the right. But in order for me to have a limit from both sides, they would both have to equal that same amount, right? So what I actually need to find here first is I need to know the limit as x approaches 5 from the left of f of x. And from the left, right here at 5 is where these two come together. I'd pick this middle function. So -3 times 5 minus 1 would give me -15 minus 1, which would give me -16. Now, since that limit from the left is not the same as the limit from the right, what would we say from that limit from both sides? That does not exist. Okay, questions? All right, now 15 asks us about the limit as x approaches -2 from both sides. So I already found -2 from the right. It was 5. from the left, at -2, you're looking at these two functions right here. The one from the left would be this one. What is our value of that function? It is 5. So they are the same here. So if they are the same, then they have that limit. It would be 5. Okay, questions? Yes.
So for that 15, if we got that problem first, is it possible to put it into the second equation?
Yeah, so if you got that problem first, if they did not ask you all of those pieces, you would plug into both equations, which you don't really have to plug into this one because it's just a 5. So you would plug into both equations, and if you get the same thing, that's your answer. But if you don't get the same thing, it does not exist. Now remember, this is different from what we did with finding values of functions. We did a little bit of piecewise functions with this. Like if I ask you for f of negative, well, not, let's do f of 5, which function should I use? The bottom one, because I got the or equal to sign, right? So I'd have negative 5 squared plus 4, negative 25 plus 4, which we found to be negative 21, right? So if I ask you for f of a number, you pay attention to whether or not you have the or equal to sign there. If you were doing f of -2, you use this top equation. But for limits, you do not pay any attention to whether or not there's an equal to sign there. All right, questions? Yes. So f of a number, you're just going to find the section that it applies to. So like f of 5 right here, it would go with this bottom one because this is x is greater than or equal to 5. So you plug into that equation. Yeah. All right, questions? All right. Okay. So piecewise functions, you just got to know which pieces to check. I think this is the last thing that last type of question we're going to do is a complex fraction problem. So these are typically the most difficult, especially if you have a natural aversion to fractions, as I seem to find most students do. So whenever we've got complex fractions, you can think back a little bit to our last chapter, which everybody loves, or verifying trig identities. If this is 1 over cosine squared x plus 1 minus 1 over cosine x, we'd have to get some common denominators, right? So it's sort of the same thing here. We need this to not be a complex fraction. So I can think of just this numerator here at first, and I need to get common denominators there. So if I do that, I could do that by multiplying this equation by 2, or this term by 2 on top and bottom, and this one by x plus 2 on top and bottom. And so we will get the limit as x approaches 0 of, here we're going to get 2 minus x plus 2. Notice I kept those parentheses there. I just want to make sure we don't forget to distribute that negative. And on the bottom, I'm going to keep it factored, 2 times x plus 2. And don't forget, you still have this denominator of x. And so we can distribute this negative here. Alright, what can happen now? Okay, we can put our like terms together, and when we do that, in this numerator right here, I got 2 minus x minus 2, so this 2 and this negative 2 go together, and what happens when we do that? They cancel. So that's leaving us with the limit as x approaches 0 of negative x over 2 times x minus 2 over x. I'm going to put this x over 1 now. And what do I do with those fractions? Flip and multiply. So, yeah, for some reason I changed to a minus for no apparent reason there. So, we got limit as x approaches 0 of negative x over 2 times x plus 2 times 1 over x. Now, I can cancel this x with this x right here. And that will leave me with negative 1 over 2 times x plus 2. Okay, so once something cancels, it usually means you can plug the number in. So let's try it. Negative 1 over 2 times 0 plus 2. So you got negative 1 over 2 times 2. So we get negative 1/4 as our answer. Alright, questions? Alright, so this is pretty much everything you should run into for your limits algebraically. You guys have that worksheet that I gave you the other day. That is what we're going to do for the rest of class, so hopefully you will have time to get all of it, if not most of it, if not all of it done. So, I am still not caught up on grading everything, and need to get stuff ready for Monday too. So I'm going to work on grading some of the stuff for Math 1 because I'm drowning in it, and they